Hi everyone, and welcome to the flipped instructional recording for 1.02 Matter and Energy. Just a reminder to be sure to take notes during the recording. You can use the unit note guide, or you can take your own notes on paper or type them out. But you do want to title your note page with the lesson number and title. So again, that's 1.02 Matter and Energy. So as we get into the lesson today, we get a good idea of what we are going to be talking about. So we learned in the last lesson that physical science is the study of nature, of the nature of matter, energy, and how they interact with each other. So we're going to focus on a simple example, the way objects behave when they hit the ground. And you'll see this theme come up multiple times during this unit. When you're dropping a ball and observing how it behaves, there's a couple labs and different things you'll do in this unit. So if we're looking at the picture here and we play the simulation, you can see we're looking at like a ping pong ball, maybe a golf ball, a pool table ball, billiards, I think it's called a billiards ball. They're very heavy. We know a tennis ball, and then it looks like a rock. So question, how are they similar? So they're all circles. They represent spheres, and after dropping them, they eventually stop bouncing. So how are they different? We can see that they're different sizes. We can see that some of them bounce higher than others, and some have, they continue bouncing longer. So some questions that we could look at based on our observations. What are the balls made out of? What makes some balls bouncier than others? Why do some balls continue to bounce longer than others? And why do balls bounce the highest on their first bounce and then bounce to lower heights each time that follows? So these are things that we're going to be looking at and investigating in this lesson as we kind of go through matter and energy together. All right, so our lesson goals would be we're going to discover and explain the nature of the materials that make up our world. So I know if you open the student guide, the document, to fill out, it's a template for you. So what's in there is just an example. It can confuse you at first to make you think that's part of the lesson, but it is a template. So each one you open of this will look exactly the same. All right, so as we get into the content of the lesson, let's take a look. Talking about matter and energy, as you may have observed in the simulation, when you drop the ball, some bounced while others did not. Eventually, the ball stopped bouncing and rested on the ground again, and some did this more quickly than others. And we'll continue to explore the concept of bounciness and the relationship between matter and energy in this lesson. So it's important to know that we're not learning right now about the actual bouncing and the ball. That's not really the content of the lesson. We're trying to study matter and energy, and the dropping of these and the height and all of that. It's just an example to help you understand the matter and energy concept. So again, we're looking at a simulation, and we're exploring the relationship between the drop height and the bounce height. So the drop height would be, if you held your hand up and released, that would be the drop height. And then the bounce height is obviously how high it bounced off the floor. So we have, it looks like the tennis ball, and you have to play it a couple of times to see where it starts. It looks like in between 60 and 70, and then it bounces up obviously lower, maybe in between 50 and 60. So it's a little bit hard to see in there. But does the ball ever bounce higher than the release height? And we can see that it does not. And then how do you get the ball to bounce the highest? Or how can you get the ball to bounce the highest? So that would be releasing it from the highest possible point. That's going to make it bounce the highest. How can you make it lowest? You'll do the opposite. You'll release the ball from the lowest point. And then what's a general statement that we could make about our observations here is that the release height is going to determine the maximum bounce height. All right, so some things to know here is height and energy. When you raise the ball off the ground and you give it some potential energy. And we'll study more about that coming up later in the course, potential and kinetic energy. So when you release the ball, the energy is turned into motion. And so here I have found an error here that I want to share with you, but consider dropping the ball from the top of the Empire State Building. So we know that's very, very high, right? 1,250 feet. And so how would the energy of that ball when it hits the ground compare to the energy of a ball released 1 inch from the ground? So we just saw up here that the release height of the ball determines the maximum bounce height. And the bounce height, those are going to be an energy transfer, right? So as we get over here and look at the answer, an object dropped from 1 inch off the ground is going to hit the ground with, this should say, less energy than one dropped from the top of the Empire State Building. All right, so we can do the math. There's a formula that you're going to learn later about gravitational potential energy, and you put in the mass and you multiply it by the gravitational constant times the height, and you'll learn that later on. And if we were to do that in this situation and just make up a ball weight, the mass, and you plug it in, you could see that this statement is incorrect, because the higher the height is going to equal more energy. So this should say drop from 1 inch should have less energy than if it was dropped from the top of the Empire State Building. So please make sure you know that that is not correct. How does this relate to your observations about bounce and height release point? So objects dropped from a greater height can bounce higher because they start with more energy. So you can see already that this has more energy when it's dropped higher. So again, this is incorrect. All right, as we go on to the next page, why did they stop bouncing? So the perfect bouncy ball would continue bouncing to the same height from which it was dropped forever. So what causes bouncy balls to come to a rest in the real world? Some energy is absorbed by the ball with each bounce. This heats up the ball. So while we can't see the change in energy, the energy is going somewhere. So what makes something bouncy? Some balls are not as bouncy as others. So take a look at this slow motion video of bouncy balls and make some observations about what happens to the shape of the balls as they collide with the ground. All right. So take a look. You're not really seeing the ground here when they hit. Are you? You can see it in the back a little bit. But look at the shape of the ball, right? Hopefully you could see that there was a change in shape. You could see that energy absorbed and then released again. So observation 1 should say the ball compresses as it hits the ground. So we did notice a compression. And the next thing we observed is that balls return to their original shape after it's compressed. So once that energy is released again, it returns to its perfect spherical shape. So what makes something not bouncy? So let's take a look at this ball and compare the observations. All right, this ball kind of hit with a thud. So our comparison says the ball does not compress like the bouncy ball. Or the ball compresses but does not expand like the bouncy ball. So I'm sure there was a little bit of compression. You can tell, like when you wad up a ball of Play-Doh and you drop it, you'll see a flat surface where it hit, but it doesn't bounce back up. So it does compress a little bit, but it's not expanding again to bounce back up. So that means that the ball of the material of the ball affects its bounciness. Materials that are elastic are bouncy. So elasticity, this is a word you might want in your notes. It's the ability of an object to return to its original shape after being stretched or compressed. And you'll see coming into Unit 2 that this is a physical property that we'll look at if something is elastic or not. Objects that compress and return to their original shape very quickly are bouncy. Other objects like pillows might compress and return to their shape, but they take longer to do so, so that makes them not bouncy. And materials like clay that compress but do not expand are not bouncy either. Rigid materials that do not compress are not bouncy and sometimes break when they're dropped, like this glass plate. All right, so that material you can see is not going to compress, it's just going to shatter. So the amount of air inside a hollow ball affects its bounciness. Have you ever tried to play basketball with a deflated ball? It doesn't work very well. The air inside the ball compresses and expands when the ball hits the ground. So if there's not enough air in the ball won't bounce. The elasticity of a ball is important in sports. So would you use a tennis ball to knock over the pins in bowling, or would you use a bowling ball in a tennis match? The elasticity, size, and mass of the ball are important properties that must be considered when you play a sport. All right, so take a look at this design challenge. So applying what you've learned about matter and energy, and design a ramp course for each ball that can knock down the block or the tower. Each ball bounces a bit differently, and there are lots of ways you can set up your ramps. So this is a fun activity for you to go through and kind of play with and learn a little bit, just kind of testing your knowledge on what we've talked about to see what happens in the different courses you've set up. And so your goal is to knock down the block tower. So you're asked to just move some of these in. You want to keep the ball bouncing. So really, let's see if we can do something here. And then we just test the ball. So that's not a good fit because it hits this. So we need to maybe put something else here so that it could go over. Let's see if we can try it again. Nope, now we can't get up high enough. So let's see. Nope, I don't think that's going to be a good fit. Let's see if we try this one with some more space. Oh, we need to move these out of the way. I'm not sure how you do that. So this is something fun you can play with. Oh, look, I made him fall over just by moving the ball. So something fun to play with, but also to test your skills on the bounciness of the ball and how that affects it moving onto the ramp. All right, and that is the last part of 1.02. So it looks like we are done there. So the next thing you want to do is just take a look. We will have a flip follow-up this week. Our session will cover concepts out of Unit 1. And then if you have any specific questions, please come see me in Help Lab and we can go over anything that you may need extra support with. So have a great day.